Good morning, student. Yesterday we were up to the calculation of Bohr radius and the velocity of the particle in the nth orbit. For the nth orbit, now we will calculate total energy of the electron. Total energy is the sum of kinetic energy plus potential energy, and kinetic energy is equal to half mv square, and potential energy is equal to q1 q2, that is the charge, q1 q2 4 pi epsilon naught r. R is the distance between two charge quantity to charge particle. Now by putting if we calculate the total energy for the nth orbit, then we will 1 by 2 we will write like 1 by 2 mvn square plus q1 q2 4 pi epsilon naught r n. By putting these two values here, we will get 1 by 2 m z square e raised to power 4 n square h square epsilon naught square. q1 if we consider q1 is the charge for the nucleus for the positive quantity, and q2 is the charge for electron, then q1 is equal to ze. For electron it is minus e 4 pi epsilon naught r, n will be equal to n square h square epsilon naught m pi ze square. So we will get 1 by 2 m z square e raised to power 4 n square h square epsilon naught square minus ze square m pi, here is z raised to power 1, so it will become z raised to power 2, z square e square m pi square e raised to power 2. Already we have e raised to power 2, so it will become total e raised to power 4 divided by 4 pi n square h square epsilon naught 2 square m z square e raised to power 4, 2 4 ja 8 n square h square e raised to power 2 epsilon naught square minus z square e raised to power 4 m pi. Here pi will be cancelled, so 4 n square h square epsilon naught square. Here we have common factor, that is m z square e raised to power 4 n square h square e raised to power epsilon naught square. In the bracket we will have, and we will get m z square is to power 4 n square h square epsilon naught square 1 minus 2, that will become equal to minus 1 by 8 m z square is to power 4 n square h square epsilon naught square. It is the total energy. So the total energy for the nth orbit will become equal to minus m z square is to power 4 8 divided by 8 n square h square epsilon naught square. So when we put it for hydrogen atom, for that z will become equal to 1, and the mass of electron charge will equal to 1.6 10 raised to power minus 19 Planck constant epsilon naught. So the total energy will become equal to minus 13.6 n square. So it will be the total energy for the nth orbit. Now like in an atom we have a nucleus surrounded by orbit. This is the nucleus, and these are the orbits. N is equal to 1, characterized by the quantized value, quantized energy level. N is equal to 3. So if we put n is equal to 1, so the total energy for the first orbit will become equal to minus 13.6. Here we will write it eV, electron volt, unit of the energy. Total energy for the nth orbit, we can say if we put n is equal to 1, of the first orbit, total energy will become equal to minus 13.6 divided by 1 square eV. So the total energy will be equal to minus 13.6 electron volt. Okay. Now for the second orbit, n is equal to 2, total energy will be equal to minus 13.6 to raised to power 4 eV. That will become equal to minus 13.6 divided by 2 raised to power 2. Here it will become 4. Then it will become 4 is at 12, 4 just 16. So that total energy for the second orbit will become equal to minus 3.4 electron volt, and so on. Here we will write, we can write E1, E2, and so on by putting different values. Now we will study the energy spectra for the hydrogen atom. As we have calculated the energy for the different orbit, like for this orbit, for the first orbit, the value of energy is minus 13.6, and for second energy level, the amount of energy is minus 3.4, and so on. So the each orbit has different energy, their fixed energy amount. So when there is a transition between these two different energy level, there will be emission of a photon. Like if we consider like if we have two energy level, E1 and E2, if there is an electron in the excited state, or we can say in the higher energy state, and if this electron make a transition to the lower state, then it will give out a photon. There is an emission of photon having energy equal to h nu. Nu is the frequency of that photon, so the total energy is equal to h nu. So the emitted photon have energy equivalent to the difference between two different energy level, that is equal to E2 minus E1 will be equal to h nu. This is the energy of the photon emitted if there occur a transition between these two energy state.